presentation from a couple gentlemen with Evertz. We have Slavisa Gruborovic and Fernando Solanes talking about an actual application of ST2110 for the M6 group, which is a large independent broadcaster in France. So take it away. I guess we'll start with Fernando.
Thank you. Okay, welcome everyone. Thank you for joining this presentation. So we're going to cover, share this presentation a little bit here today, and the idea here is to cover some of the details within the M6 project. Go ahead, Slav.
Okay, so in order to make an end-to-end IP solution, there are a couple of things that need to be met. First of all, you need to have advanced orchestration layer. We'll get in more details on that. Monitoring analytics tools, especially when you have more and more different vendors together. So you need to know where your signals are coming in and going out, and if there are any issues. And the third most important thing here is the interoperability between these vendors. Because you need to make sure that the standards such as ST2110 as well as the NMOS are compliant along the side of all the different vendors within the given system. Standards and challenges. First of all, why are the standards important? It enables efficient workflow throughout the system, interoperability between different vendors, which we'll get in a few minutes on different vendors that were involved in the M6 project, troubleshooting and diagnostics, making sure that when I have an issue with one vendor, I don't have to call that vendor. You can call one central vendor depending on, in other words, whoever is the orchestration layer, that vendor would be dealing with any issues. Confidence. Confidence is confidence from perspective of the end user, confidence from perspective of vendor A, vendor B, vendor C, making sure that everybody is on the same page throughout the deployment of the system before and after.
I think to kind of add to that, I think one of the biggest challenges when deploying any facility for any vendor, regardless of who they are or whatnot, the really interoperability has been the biggest gap. We've been Evertz has been deploying IP systems for a number of years and definitely very large systems and working and so forth. But when you really start to get into, well, now we want to choose this product from this vendor and that product from another vendor and so forth, interoperability and testing of things as much as we can in advance is important. Sometimes you don't have all that luxury, right, of being able to kind of pre-build a system in any vendor's particular facility, because if you're dealing with vendor A, he wants to basically have everything at his facility. You've got vendor B, he wants everything at his facility. So, in many cases, the actual build site is the first time that you're going to have all vendors kind of cohesively in one environment. And we try to avoid that in any case you can, but depending on the size of the build, that could be the first thing. So definitely things like this where we talk about interoperability, this is one of the very key factors and arguably the largest challenge across any IP install.
So I'm not going to get much into details of NMOS 4, 5, but these are the main ones that the M6 dealt with. So registration and discovery of third-party devices, specific version of that's approved, as well as any open API devices. And then ISO 4 connection management. Right now it's version 1.0, but then again, as new versions come up, each vendor has to support that specific version, as well as orchestration layer itself.
This is, in talks of kind of the compatibility, Slav, we went through this where currently, we're M6 implemented devices that are both ISO 4 and ISO 5 compliant of these revisions. And a question that comes up often is having some sort of a matrix that says, hey, this vendor is supporting this version and of this hardware with this, other vendor and so forth. And so it's easy to think of a simple sort of matrix that says, this device is compatible with this version of ISO 4, ISO 5, but I think one of the realities is, because we can say it's easy, but one of the realities is that because it's so fluid, the standards themselves are relatively new, and as more vendors come into play, adding something for one vendor may in turn, lead to kind of challenges with other revisions with other vendors that may not have been, brought or implemented that same revision and so forth. So I think, again, we try to keep a positive outlook of what these standards are really doing for us and helping us out. But in the same token, there's obviously a broad range of instances that come into play with these challenges. Additionally, something else that comes up, and we've kind of faced this a number of times, was the question of, do you use these standards over maybe a native or proprietary control of a particular third-party device? So, there's instances where we talk about being able to have open standards, to have the best of breed and so forth. But sometimes then you may say, well, this control system has native control to that particular third-party device, and it may actually offer more flexibility within that control. It may not be an open piece. So that's actually another question that comes into play every once in a while. Is this, at the end of the day, what are we trying to achieve, right? And if it's, while we want to, definitely everybody wants to work kind of with an open book to make sure that things move forward. Really the end game is to be on air and supporting a facility overall, right?
Yeah, just to add on that, specifically for M6, you will see later in a few slides, some vendors were NMOS 4.5, some vendors were through an API rather than the NMOS 4.5. So basically, the agenda would be project background. I'll give you some idea what the project was intended for, proposed solution, current steps and future steps, what's next, and then in the end, questions. So M6 themselves, they have main and backup facilities, completely different infrastructure. One building is main, one building is backup. They're some kilometer apart. So the idea of them was to upgrade their existing system, which was deployed in 2008. So they wanted to upgrade from HD to HD, but with capability of going 3G and 4K, while taking into account the latest and greatest technology, being 2110 and NMOS. So project was divided into two phases, phase one being the main facility, and phase two being the backup facility. Main difference between main and backup facilities: on the backup facility, they're backing up only 5 to 6 channels, rather than backing up everything. So solution that was proposed to M6 consists of multiple vendors, some being SDI, some being NMOS 4.5, as well as 2110 compatible. In other words, 2110 and being an IP. So for anything that was SDI based, we had the IP gateways to encapsulate, feeding into, I can't walk around, feeding into the feeding into main and backup media switch fabrics. Also for multiviewers, we were using 2110 multiviewers. So 2110 stream comes into the multiviewer processes it and makes a mosaics. Mosaics at 2110 kicked out through an HDMI converter to monitors. Furthermore, some of the third-party devices were Playout server. This was Harmonic Spectrum Max. They were NMOS 4.5 and fully controlled by the orchestration layer. Graphics, unfortunately, in order to meet the timeline, they had to go with the SDI. So they were encapsulated around the gateways. Right now, we are working together with them to move to IP completely, and that will be also NMOS 4.5. Furthermore, the audio monitor 2110, it was only through an API. So an API was produced to be controlled by Magnum. And
so yeah, so this is one example where you've got a vendor that has obviously reached the 2110 level of working, but hasn't yet fully implemented control. In other cases, it's the other way around. They're actually, in most cases, it's the control aspects that the more challenging one. 2110 now for most of these vendors or the large-scale vendors are pretty much there. There's the occasional we supported in this level of configuration. Another one, audio, I think, was one of the ones that it's also the challenging question of it's such, 2110 has a wide range of audio support and different. There's still a lot of questions as to, when you support it, which versions you supported. When you're stating that you're supporting 2110, you're supporting every model. Is it mono channel? Is it 32 channels? Is it so? There's still a lot of kind of back and forth. We at Evertz particularly use an audio subsystem, to kind of offer some of that changing from one support to another. But I think the end game, right, is to be able to ensure that you're able to take in just native any to any and be able to feed it through. So there's a lot of considerations. A lot of that depends on the scale of the facility as well, and look at it from that perspective. But yeah, I think this was probably one of the builds where we we really started to see the other vendors come through, particularly with some ISO 4, ISO 5 capabilities. 2110's been pretty solid already, I think. Yeah.
So the whole idea of solution was for them to upgrade their master control room as well as their playout system. And it was, of course, to be 2110 deployed. This project started end of 2017 with the timeline slowly moving forward. And as of July 2019, they deployed first 2 channels. September 24, they'll be deploying 2 additional channels. And then later on, I believe November, December, they'll be finishing with additional 6 channels. So this is actually the view of their current 2 channels playout, which I'll get into more details later on in the slides. So as mentioned before, the solution for your media network switch, it's 2 IP cores, main and backup, with low latency and in order to route your 2110 multicast throughout the facility. As Fern mentioned on the interoperability, that's the key point on with the M6 project. And this is basically what the challenges came up, whether or not they're 2110 ready, whether or not they're NMOS compliable or not. So the M6 system had 4 third-party devices in addition to Evertz devices: Tektonic Prism, Harmonic Spectrum X, Ross Expression, and TSL PAM. Out of these 4, harmonic playout control was through NMOS with Magnum. Ross Expression, unfortunately, as we mentioned before, due to the timeline, they were not ready with the 2110, so they had to proceed with the SDI cards. And right now, that's being worked by Ross and Evertz to make sure that the card goes into IP, and then they'll go either NMOS 4.5 or maybe API, whichever one is easier. TSL was connected directly through from IP core to the TSL, as there was no requirements for any routing. It was static to be only. So main goal of M6 was to make sure that they can fully control all of their 2110. They wanted to make this as easy as possible for them. In other words, they didn't want to have to think about what's happening in the background, what's going on, and any issues happening. So this was powered by the orchestration layer, specifically Magnum, and the user-friendly interface, which we'll get into more details later on in the presentation.
Yeah, I think, one of the great things about 2110 kind of being solidified and already tested for a number of years has been that now customers are beginning to focus on operational workflows and efficiencies that they can bring in with IP. So before it was really, the first year or so of building IP systems, it was really just wrapping gateways around everything, and you're building these massive routers. But at the end of the day, they were primarily SDI. You weren't really focusing on taking advantage of what IP really offered. And now this is something that I would argue in the last, I'm going to say, 2 years is starting to ramp up, and now it really is the focus. So we're not really talking so much about, well, Evertz sells this gateway and another vendor sells another gateway. I mean, at the end of the day, they're all kind of encapsulating these signals. But now it's more about what are we doing with those IP signals? How are we presenting this content now to the operational interfaces for the day-to-day users of a facility, as well as then how do we present the maintenance of the facility? And Slav will have a couple slides showing some of these, but this is really kind of some of the advantages.
Yeah, so for example, this is the orchestration layer, different interfaces to your devices, device interfaces to your core, multi-viewer, and interfaces to your different interfaces that you can pull out throughout the system. So this is basically the orchestration layer, which makes it easier. Basically, it's running in the background. This is the brains of your system. I don't have to worry about what's going on. And
Yeah.
no.
General.
2 points that I want to point out that the M6 want to make sure is visibility of their system and configurability. Visibility meaning that they want to make sure that they have full vision of their signals coming in and out, the bandwidth throughout the system, and this was to be accessed as quickly as possible, which was access to the web interface, which we'll get in a second. Configurability, meaning that if they have another, let's say, 5th vendor tomorrow, they can easily configure it, bring it up into Magnum, and set it up throughout the system. So this is specifically the Spectrum X, actually the NMOS registration, bringing the Spectrum X into the Magnum. How easy it can be accessed, how easily it can be configured and set up in the Magnum.
Yeah, I think kind of the biggest takeaway from the next couple of slides that cover some of the NMOS implementation is not only trying to come up with an interface that works for the service people that are deploying the system, but an interfaces that are intuitive for the day-to-day managers and the day-to-day engineers that are working on that facility to be able to maintain it as a whole, I think, right?
This is just an additional tool for NMOS to be added to the system. So this is network discovery system, making sure that easily you can add any additional product into the Magnum itself. Bringing the new products in, or taking the ones that you don't need anymore, taking them offline. So as I mentioned before, the easiness of user interface. So this was specifically for the 2 channels that got deployed earlier this year, so in July. It's the Siri Club and Siri 2. So the couple things that I want to point out here, where's my mouse? Yeah. So this is one single view interface for one operator, taking care of 2 channels, for example. So on the bottom here, you can see different sections, which I'll go through each slide. Basically looking at the monitoring, live feeds, diffusion, simple XY routing, Vistalink, which is the VL Pro, so the network management system, monitoring of your health of your systems, and then the alarm setup. So to go through this monitor, they had the servers, sources, process, and the part, and I'll explain more into details on each one. So sources, these are their external sources coming from as a baseband into the system through the Spectrum X. So they wanted to make sure that they can monitor all of these at one single point.
So we'll skip through a couple of these, but this is one of the, it's kind of hard to tell in a slide, but this is, so basically this is a touchscreen interface sitting in front of the operators at the control point or their control room. And one of the interesting things is that this is now becoming extremely common, right? Where now the operational interfaces are offering not just a button that that says something, but actually an intuitive interface that represents a change, represents an action. So you're able to watch the video, it kind of be processed in real time, if you will, from an input to an output, and what that processing did to the video, audio shuffling, audio mixing, and so forth. So all this now becomes kind of this intuitive interface, which really is something that while it may have existed in the past, it's never existed as efficient as it has now in the 2110 space, because you're really able to come in and out of your IP fabric numerous times without really having the same cost implications that you would have had in the SDI world of watching every single step of the process. So I think this is something that each one of the different steps, so they're looking at it pre-delay, after delay, or after an up-down cross, and so forth, and you're able to kind of visualize these things directly at your desk or in a control room environment. So we always get the question of, when are we going to start building the first control room that doesn't actually have a massive monitor wall in the back? Because at the end of the day, if everything is available at your fingertips, are we really changing that environment? And I'd probably say it's not going to be next week or anything like that, but we're heading into that flexibility where now we're able to do so much, at the tip of your finger, and really bringing those interfaces and flexibility up close to the users. We're going to run short on time on a few of these, so I'm going to skip a couple of them.
So let's just on XY. This is so basically this is replacing your hardware control panel. Here you have a simple interface, sources, destinations. So for this specific one, these are the sources related to Serial Club. Of course, the operator has access to all of the signals within the system. Simple source, destination, take. Vista Link, so this is basically for the Serial Club. So basically, if operator clicks here, the Vista Link Pro comes up for the monitoring of your signals within that specific flow. So Serial Club signals monitoring of input signals into the IP gateway, monitoring of your signals from IP gateway to the IP core, as well as monitoring of the bandwidth. You'll notice the red because this one is 0 bandwidth, so it flags it automatically.
So what's definitely important about this slide really is many vendors have been monitoring different points within their facilities in the past, but what's unique now is that this is absolutely necessary now in a facility. Prior to, you could have been able to say, okay, you've got your patch panel and you can triple check in a couple of areas. In the world of IP, these software tools are really where the strength lies. It's really what you need to kind of see every little step of the way that of signals traverse through the facility. So strong tool sets again that are gonna show all these different areas and in many cases even maybe traverse standards as a whole, right? So you may be going for 2110 into a compressed format and then back out and so forth, or processing your up down cross and features and stuff like that. So I think this is where I guess at some point we're going to be spending a lot more time just talking about the operational interfaces that we're offering, not just for the operators that are running the show, but the operational interfaces that you can offer to the broadcast engineers that are maintaining, and how are they configuring these things with ease.
Yeah. And then, of course, if they press on Sequire 2, you'll have exactly the same layout, but for the channels of that specific, for signals of that specific channel. Future next steps. So as I mentioned, they already deployed 2 channels in July of this year, 2 more channels coming in September 24th, and 6 channels towards the end of this year and beginning of next year. And then phase 2 starts once this one is deployed completely. So phase 2 would be basically their backup facility, which would more or less be a copy of this. So main and backup IP cores, 2110, NMOS, and by then you would have all the vendors hopefully by that time and NMOS compliable as well as 2110. One thing that I want to point out is point number 4, which is key. Continuous collaboration between the vendors and the end user. I specifically said end user because it doesn't matter which customer it is, there has to be a continuous discussion between vendors, different vendors, and the customer. Even though if the system is currently deployed, there has to be continuous discussion afterwards to make sure that the customer is fully compliable.
Yep. Yeah, I think kind of to the point, I think at the end of the day is M6 with this facility build, has deployed and is satisfied. good to have deployments like this to continue to kind of grow and scale them, kind of break the boundaries of where we are with the technology. But overall, yeah, I think definitely it's always a kind of step forward progress, right? So,
That's it.
all right, thank you very much.
Any questions?
Leave it open for any questions. And well, Slavisa will hang around a little bit after the fact, so if there's any other questions after, then we're good to go.
So I did have one question. When you're building the next phase, phase 2, what do you expect to be different from what you're doing in phase 1? What improvements can you do? You know, can you make things better in any way? What do you think is going to happen in that respect? Because you're getting newer equipment, more time.
I think in general, it's every day is a new advancement, and you learn your lessons from your first build and so forth. But definitely, I'm going to say, beyond the fact that you kind of interoperability continues to improve, I think the best thing is that as the customer now sees the power of what IP can do for them, now they begin to build these new technologies into the workflows that they've always envisioned, and that freedom of flexibility comes at play.
Any other questions? Okay.
Thank you very much.
Thank you.